Okay, this short video is on how to write electron configurations for ions. And we will be doing both full and condensed configurations. And we will also be looking at what this idea of a noble gas configuration is. All right, so the ions that we are going to be dealing with today are going to be fluorine minus and magnesium 2 plus. All right. So the first thing that you do, that you always do, as I've said in all of these videos, is the number one thing you do is you count the total electrons. All right. So we're going to do that for fluorine minus, and then we're going to do that for magnesium 2 plus. I will move those apart just a little bit. So first thing you do, you find fluorine. There's fluorine. Atomic number 9. Therefore, the number of electrons is going to be 9. That's where you start anyway. That is a negative charge. Remember that electrons are negative. So that means that there is an additional electron. And so fluorine minus has 10 electrons. Next, we're going to take a look at magnesium 2 plus. So magnesium, atomic number is 12, starts with 12 electrons. Remember, it's got a 2 plus, and electrons are negative. So that means it lost 2 electrons. So I'm going to subtract 2. Oh, and guess what? It has 10 electrons. So your basic rule is if you have an anion that's negative, you're going to add to get the total number of electrons. If you have a cation, and that's positive, you're going to subtract in order to get the total number of electrons. Total number of electrons. All right, so there you are. There's your basic rules. Now, what other element happens to have 10 electrons? Well, let's see, shall we? It is neon. Neon has 10 electrons. And guess what? Neon is in group 8. Group 8 are the noble gases. So that means that everything here looks exactly like neon. Neon is a noble gas, and so everything will have a noble gas configuration. Now, let's do our full electron configuration for something with 10 electrons, because they all have 10 electrons, right? So we'll start with F minus. So I want to have 10 electrons, right? So I'm going to go to my electron configuration periodic table, and I'm wanting to get there. That's the one with 10 electrons. Okay? So I'll make myself a little note right here. This is the one with 10. All right. So I'm going to start here at the 1s. There's 2 electrons can be in the 1s, so I'm going to have a 1s2. From there, I'm going to move down to the next period, 2s, 2s1, 2s2. So I'm going to have 2s2. Then I'm going to move over to 2p, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. 2p6. The noble gas configuration is that it is a full valence shell. Let me circle the right thing. It's not the fact that it's 2, it's the fact that it's P6. That P6, that is a full valence shell. That is a noble gas configuration. Or we will often abbreviate it C. All right. Now, if we want to do a condensed configuration, like say for magnesium 2+, we have the same target as we had before, right? That one right there. So we go up to the previous period, we go all the way to the right. What element is that? That element is going to be helium. Okay, that is our noble gas. So condensed configurations always start with noble gases. So that is going to be helium. Now helium, remember, already has 2 electrons built into it. So then from there, we're going to do what we did before. We're going to go down to 2s, 2s2, that brings us to there. 2s2. And guess what? 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. So we end up with 2p6. So, in summary, helium is that bit right there, right? And then the noble gas configuration is the fact that we have the P6. And those two things are exactly the same because they have exactly the same number of electrons. And so we do have a word for that. F minus has 10 electrons. That is the same as neon has. That is the same as Mg2 plus has. We call those isoelectronic because the word iso means same, and the word electronic, of course, means electrons, and so that particular word means same number of electrons. Same number of electrons. All right.